Whatever problem you want to solve, there are hundreds of potential open source tools that can help you. Some are better, some are worse, but when it comes to security, you don't want to mess around. We at JIT build a security platform that leverages open source security tools. In order to figure out the best ones, we needed to go on a tool checking journey. I would love to share that with you. Hi, my name is Aviram. I'm co-founder and chief product officer at JIT, which is a continuous security platform for developers. What this means is we help dev organizations build secure applications from day zero by automating security plans using open source tools that we have curated. We have researched and tried hundreds of tools to choose the best ones for our needs. We tested the tools on real projects and got real results. This means that we are very much familiar with various open source security tools that the market has to offer, and I would like to share insights with you and generate interest among you regarding these tools. There are many properties we use to rank the security tools. Here are some of them. We want to see a tool that actually detects what it should, true positive rate, high true positive rate, and that it has low ratio of false positive. We want tools that are easy to use, their output makes sense, and the tools in general should be easily integrated into the CI. We want a tool that is supported by large communities of developers and that in general is maintained on a regular basis. In terms of ownership, we see some advantage when there is a prestigious company behind a tool, because it creates a standard. In terms of GitHub stars, these stars are a good indicator that the tool is popular. We also consider that as one important property. And also licensing. We want tools that are free. And we have some preferences to permissive licenses such as MIT and Apache. These are the security categories that we will focus at, these 5. Though there are many, I believe these 5 categories are a good starting point. So let's start with dependency check. The mission of dependency check, also known as SCA, Software Composition Analysis, is to detect publicly disclosed vulnerabilities in project dependencies like packages, libraries, and so forth. In the list, in our list of contestants, we have 3 tools which all of them are good: iterate.js, OWASP Dependency Check, and NPM Audit. All of them detect node vulnerable dependencies. We decided to go with OWASP Dependency Check. Yeah, that's because of a few reasons. Usability is super. Efficacy is very good. High rate of true positive, yeah, there are some false positive, but very good rate of true positive. It's very easy to use, and it's also very popular tool, so we recommend using it. In this example, we see that there is a dependency named ADM zip. It's a JavaScript implementation for zip data compression for Node.js. And it is used in this project. The dependency, I'm telling you in advance, the dependency contains vulnerability. So let's see how OWASP Dependency Check faces that. So you can see this is the output of OWASP Dependency Check, and it identified that this dependency, the ADM zip, is associated with 3 CVEs with severity level of critical. Okay, let's move on to the next category, which is secret detection. The mission here is to detect hard-coded secrets in various formats. So this could be password, SSH keys, AWS credentials, and more. The tools do that by employing regular expressions, many various regular expressions, and by calculation of entropy. We compared between three tools: Git Secrets by AWS Labs, Detect Secrets by Yelp, and Gitleaks, which is owned by individual developer. All of them are good and free. We decided to go with, so we chose Gitleaks. It detects hard-coded secrets like passwords, API keys, and tokens in local and GitHub repositories, private and public. Some pros for Gitleaks: very good detection rate. It's very easy to integrate to the CI. It is developed with almost 100 contributors, and it provides reporting in various formats. When compared with the other two tools, we prefer to go with Gitleaks, even though the others are good as well. So this is an example of a key. And this is the output of Gitleaks. You can see that Gitleaks identified the secret and associated with a rule that is called AWS access token, because it obviously matched a regular expression built for AWS access token structure. Okay. So the next category is Terraform scanning. The mission here is to detect security vulnerabilities, cloud misconfiguration issues, and all of that by analyzing the infrastructure as code, which is very important security capability for those of you who work with infrastructure as code. We have compared many tools. The top were Chekhov by Bridgecrew, now Palo Alto, KICS by Checkmarks, and TFSec by Aqua Security. The good news here is that all tools are great. They are backed by good companies, and they constantly improve, and they do their job. All of them, by the way, are either MIT or Apache. But we decided to go with KICS, and that is for two reasons. First, KICS has exceptional detection rate that we loved. And the other reason is that it includes indication of severity, which is very useful for prioritization for DevOps people who are not security experts. So the indication of severity was for us an important property of KICS. So in this example, we have a Terraform module where EBS data is not encrypted, as you can see in this example. And KICS identified this misconfiguration and ranks it as medium, together with sharing detailed description and guidance how to fix it. See, medium and the relevant description. Next category is the runtime scanning. The mission here is detecting vulnerabilities in web applications while they are running. That includes also API scanning, and it can run in a non-authenticated mode, what we call black box testing, or authenticated mode, what we call gray box testing. The contestants here were OWASP ZAP, Nikto, and Arachne. All these tools can help you evaluate the security of web applications, and each of them has above 3K stars. So they do their job, and they are popular. In this category, we decided to go with ZAP. It's a very popular open source DAS tool. It is maintained by the OWASP Foundation and has been around over a decade. We chose it over the others for this reason. It includes authenticated and non-authenticated web app scanning. It includes API scanning. It has good range of features like vulnerability scanning, fuzzing, reporting. It is well supported by a large community. In this example, ZAP scanned a web application and detected that the Content Security Policy, CSP, header is not present in the server response. Essentially, the CSP is used to prevent cross-site scripting, clickjacking, and other code injection attacks. So it's great that ZAP identified it. And final category for today, container scanning. The mission here is to detect vulnerabilities from all sorts in container images. We reviewed and tested various tools, but two topped the chart. Trivy by Aqua and Claire by Quai, now part of Red Hat. We decided to go with Trivy due to its efficacy and easy integration with the CI. Here's an example of output when Trivy was scanning a Docker image that I created based on Debian 11.3. So you can see that Trivy identified the vulnerable library. Cool. Now, let me show you a quick demo about integrating these 5 security tools into the CI pipeline. I'm using GitHub and GitHub Actions, and you can view the demo repository in this link I created. Okay. So first, let's take a look at the workflow file. So you can see that the workflow file is the jobs here are triggered by push. Okay, and there are 5 jobs here. One which deals with secret detection. Here we run Gitleaks. The next one, the dust, the runtime scanning, we use ZAP. For the infrastructure, as code scanning, we use KICS. For the SCA, we use dependency check. And for container scanning, we use Trivy. All these jobs run in parallel whenever I commit a new change. So let me do that. I will just add a space here. Commit a change. And you see that the workflow kicks in. So you see that all the jobs run in parallel. And I see that the secret scanner finished. So if we drill down, we can see that what we can see is that a password, a secret was detected in a file named Docker file. The secret itself does not appear here, but you can see that that Gitleaks actually detected the secret, and now you can see it gives also the line number, line 8. So if we'll go to the Docker file, line number 8. Cool. Okay, so we see that dependency check also finished. If we drill down, we will see that the report was uploaded. And I'll show you later on. And container scanning also finished. So we see the detection of Trivy in here. The dependency check. This is the dependency check report that OWASP dependency check created. And this is the report that ZAP created. Okay, and let's see also the infrastructure as code scanner. In here, you can see, for example, that KICS found DynamoDB table not encrypted. It gave it medium and provided some details about it. And also the alerts also appear here as annotations. Cool. So you have access to this repo. You can clone it and play with it. Okay, let's go back to the deck. Okay, like you see, there are plenty of excellent open source tools that can be used. Yes, even for things as important as security. And it's very possible to build an entire security program only by using open source solutions. At JIT, we took it into the next level. We enable users to manage a security plan and fully automate it with a continuous security mindset. We do that in conjunction with providing a dev-native experience by adding comments inside the PR, so developer can have a great user experience, more than just drilling down into the output of every tool in the CI itself. At JIT, we automate security plans and provide a great dev experience. So that's about it for today. I hope it was interesting for you, and thank you very much for joining. Bye-bye.